Hey, first of all, I just want to take a second to thank you for taking the time to look at my project board. I really appreciate it. I'm a kid from Norway and I love building AIs. I built image classifiers, language models, and chess AIs. So I love everything AIs, and I'm going to continue building much more in the future. So, what did I build? What is this showcase about? Earlier this year, when I was looking for a project to build, I looked into how ChatGPT was made, and I found out that it was made using an architecture called the transformer. Now, a transformer is a type of neural network architecture which incorporates several elements, which I'll talk about later in this showcase. And they're used for a variety of use cases like language processing, and image generation even, and language generation like ChatGPT does. So after learning a bit about transformers, I decided to write an article on them because I find that writing an article is a really good way to learn. So I did that, and then I thought, maybe I should actually make my own transformer in code. So after doing some research, I found out that it isn't that difficult to do, and that you can do it just on your own computer. You don't need like a supercomputer or anything. So I decided to make a transformer which takes manuscripts from Shakespeare and uses that to train itself on how Shakespeare writes, and then outputs a piece of text that looks like Shakespeare. This is the GitHub repository for the transformer, and we can use any long piece of text to train it on, but I decided to use the Shakespeare dataset because there are lots of good datasets available that are easy to work with. So the goal of our model is that it takes an input in the form of what it already has generated, and then decides what it thinks the next letter should be. So when it trains, it takes one part of what Shakespeare has written in the manuscript and then tries to predict what the next letter should be. And then if it's right or if it's wrong, determines how the model should train. And when it generates something itself, it just makes one letter, and then it's already been trained, so it should know what it thinks the next letter should be, which is how it generates something. So how this works is that we first have a token embedding table, which basically just takes the input words and turns them into numbers so the computer can understand them. In our case, we're using single letters and not whole words though. Then it adds a self-positioning embedding table. It adds a list of numbers to these numbers generated from the text, telling the computer where letters are in relation to each other. Then we have self-attention, which is here, and this tells the computer where different letters are, or which different letters are important to which other letters. So it makes the computer better able to understand how to form the context of a complete sentence, not just single letters after each other. Then we feed the output of this through a fully connected neural network, adding some non-linearity. Then we feed it through a softmax, and it returns what it thinks the next letter in the sequence should be. So it generates one letter. After training the model for about an hour on my computer, this is what it outputs. And even though it doesn't make complete sense, it's still quite interesting how faithful it looks to Shakespeare. So what I've learned from this is that you can train really complex and amazing AI models just using your own computer. You don't even need to have a supercomputer or anything. It's a very approachable field for anyone, and it makes me happy and inspired to continue learning more about AIs in the future. To finish this project bar off, I'll just say that if you're in the showcase right now, you should come up to me and say hi. I would love to speak to you. And if not, you can add me on LinkedIn or send me an email. Details are featured on screen now.